Hello everyone, in this video I'm going to walk you through how to answer every single question that appeared in paper 2 of the 2024 Year 6 SATs. Question 1, here is a triangle on a grid. You can see we have the image of a triangle, we have a grid, and you can see in the middle there's a dotted line which is labelled a mirror line. The question is, draw the reflection of the triangle in the mirror line. Use a ruler. This use a ruler is really important. If you don't draw the line straight, you will not get the mark for this question. So I'm going to zoom in a little bit to show you this question. So when you have a mirror line that is straight, so it's either a vertical or horizontal, we simply count from each point of our shape to the mirror line and then beyond. So if we were to take this vertices here, actually what I'll do is I'll change the colour on each one so that you know which one I'm doing. So if we were to take our red vertice first and we count to the mirror line, it's 2 places to the mirror line, so we're going to go 2 spaces beyond, and that's where that part of the triangle is going to go. If we go to the blue part of the triangle, we can count 1, 2, 3, 4, 5 to the mirror line. So 1, 2, 3, 4, 5 beyond the mirror line, that's where that vertices goes. And then if we go to the green part of our triangle, we'll go 1, 2, 3, 4, 1, 2, 3, 4. Now when you've got all your vertices on, then you can join them up with a straight line. It is really important that you use a ruler and that you're very, very accurate with joining up in the corners, because your examiners do have this digitally on a computer and they can zoom right in and the computer will measure how far out you might be from the corner. So make sure you're as accurate as possible. You have a sharp pencil and you use a ruler and keep a steady hand. Question 2. This table shows the cost of fruit at a school cafeteria. We have a table with fruit and the price down the other side. Amir buys 2 pieces of fruit and he pays with a £2 coin. He gets £1.50 change. Tick the 2 pieces of fruit that Amir buys. So this is a 2-part question. First of all, we have to take note that he pays with a £2 coin and that he gets £1.50 change. So from that will help us to figure out how much he spent. So if he spent £2 and he got £1.50 change, that is simply £2 subtract £1.50. And that is 50p. Hopefully you can do that mentally. If not, you can use a written method. So we know that he spends 50p. So we now need to think about what 2 pieces of fruit he could buy for 50p. So a bit of trial and improvement here. What I would do is I would have a little look at my first one, for example. So if he bought a banana for 50p, remember 2 pieces of fruit cost 50p. If he bought a banana for 12p, what is the complement to 12 to make 50? And actually it's 38. So you just need to see, is there another piece of fruit, is there another number that adds to 12 to make 50? And there in fact is. The 12 and the 38 make 50p. I don't need to go any further. If you had started with plum, for example, a plum is 23p, then I could say, okay, well 27p would make the 50. There's no fruits for 27. If I looked at the apple, 32p, I'd need another fruit for 18p. Okay, so it just depends how you would start. I would start systematically at the first one, and it just so happens that that is the right one. So it's banana and it's pear. Question 3. Layla plays basketball. This graph shows how many points she scored in her first 3 games. So you can see your graph. We have going up the y-axis the number of points. You can see it's going up in 2s, and we have across the x-axis each game, and they are showing in bars. After 4 games, Layla has scored a total of 25 points. Complete the graph. It's very important to note that this is a total of 25 points. It isn't 25 points in game 4. Be very careful, that's the sort of thing that trips people up. In fact, it doesn't even really let you make the mistake because the graph only goes up to 12. So what we need to do is we need to figure out how many points has she scored so far. So you might want to do something like label each bar. That's what I would do. So I'd go to game 1 and I can see it's between 6 and 8, so that's 7. Game 2 is between 4 and 6, so that's 5. And game 3 is bang on number 10. So I can see how many points are scored in the first 3 games, and I'm simply going to add those up. So 7 plus 5 plus 10. 7 plus 5 is 12, plus 10 is 22. Okay, so she scores a total of 25 points. After game 3, she'd already scored 22. Therefore, she must score 3 points in game 4. So we need to complete the graph using a ruler. Game 4 is going to, 3 points is going to be halfway between this 2 and 3 line. So you want to be imagining the top of your bar being here between the 2 and 3. I would put your ruler down like this along, and then just draw the top of your bar on top of your ruler right above game 4, so that you're left with something like that, and then you can draw your vertical lines. So again, use your ruler because examiners can zoom in. My lines aren't perfect. I'm using a digital tool. Using a pencil and a ruler by hand is going to be a lot more accurate, but that's how you want to show your graph. Question 4, the numbers in this sequence increase by the same amount each time. Write in the missing numbers. So you can see that we have 2 spaces to fill in, this one and this one. All we need to do is figure out what the difference is between each number. Now we have 2 numbers that are next to each other, so this is going to be the key for finding out the difference. We just need to see what the difference is between 1 and 7, which is quite simple. You should be able to do that in your head. The difference between 1 and 7 is 6. So we are adding 6 each time going that way. So that way we add 6. So from 1 plus 6 is 7, 7 plus 6 is 13, and then we can just check 13 plus 6 is 19. I'm happy that that's correct. And then we're going to work backwards. We're doing 1 subtract 6. Now if you are unfamiliar with using number lines and negative numbers, I do have lessons on that in one of my courses, which I can link in the comments. However, very quick lesson now. I always think about my 0. I'm on 1 and I want to take away 6 because I'm going that way. To get to 0, I'm taking away 1. I've got 5 left to take away. So therefore it's minus 5. Now I'm just going to double check that from minus 5, if I took away, so there's my minus 5, if I took away 6, that I got to minus 11, and yes I do, minus 5 take away 6 is minus 11. I'm happy that those are the 2 missing numbers. Question 5, write 3 missing digits to make this multiplication correct. So this is really showing your understanding of multiplying, as well as the multiplication method. So we've got something multiplied by 3 ends with a digit of 2. So if we think about our multiples of 3, if I jot them down, 3, 6, 9, 12, 15, 18, 21, 24, and we only need to go up to times 9 because it can only be up to 9 as the answer. You can see this one is the only one where there is a 2 in the ones digit place, so it must be times 4. So this must be 4 times 3, and then that means that this is 12. Now we know that this calculation now is 5 times 3, which we know is 15, but because we know there's a 1 here, it's going to be 16. And we now know that something times 3 is actually going to make 6, not 7, because we've got a 1 here. Wherever we multiply by 3, we're going to have to add this 1 to it to get this answer of 7. If we look down our multiples list, and we know it can also only be a single digit answer, so it's only those top 3 it can possibly be, and we know it needs to be 6, so it's actually this one here, so that's 2. 2 times 3 is 6, plus 1 is 7. Question 6. Olivia is thinking of a number. My number is greater than 236, it's less than 245, it has a 3 in the tens place, and it's an even number. What number is Olivia thinking of? So what we're going to do here is start with her clues. Now the first 2 clues give us a range of numbers, so it's greater than 236 and less than 245. So that means that it could be 237, 238, 239, 240, 241, 242, 243, 244. Now, you didn't have to write all those numbers down. I'm just showing this to you to demonstrate, because you could have looked at this last clue. It's an even number to eliminate some of these. It says it has a 3 in the tens place. So that already eliminates all of these, because all of these have a 4 in the tens place. And then, so I've used that clue, I've used that clue, I've used that clue, and finally it's an even number. Well, it can't be that, and it can't be that. We only have one possibility. So the answer is 238. We just simply followed the clues. Question 7. A box holds 40 packets of envelopes, and each packet holds 25 envelopes. How many envelopes does the box hold? Now, I'm going to use the bar method to represent this visually, so you can see how this helps to visualize the calculation you need. So I'm just using the first bar to represent the 40 packets of envelopes. So these are the packets. So these represent the 38. I'm not going to draw out the whole 40, okay? And it says each packet holds 25 envelopes. So that holds 25. Each of these 38 hold 25. That holds 25. Now, what you can hopefully can see is that we have 40 lots of 25. So we're actually doing 40 multiplied by 25 to get this answer. Now, you might want to do that as a long multiplication like that, or you might want to use known facts. So I know that 4 times 25, this is a fact that you should know. 4 25s make 100, because 25% is the same as a quarter. So we know that 25 fits into 100 4 times. So 4 lots of 25 is 100, then 40 lots of 25 is going to be 10 times bigger, it's going to be 1,000. So the box holds 1,000 envelopes altogether. Question 8, write a whole number in each box to make the statements correct. One has been done for you. Just take note that the whole number is written in bold, so it cannot be a decimal number. One's been done for you. 18 rounded to the nearest 10 is 20. So a number rounded to the nearest 1,000 is 4,000, and a number rounded to the nearest 10,000 is 820,000. Now, I would use a number line for this. If we're rounding to the nearest 4,000, I'm going to put 4,000 in the middle, because the number could be smaller than 4,000 and it could be bigger than 4,000. If we're rounding to the nearest 1,000, then it's the hundreds we're looking at. Anything bigger than 4,500 would be rounded up. So 4,499 is the largest number that could be rounded down to 4,000, and 3,500 is the smallest number that could be rounded up. So 3,499 would get rounded down to 3,000. Because when we're rounding to the nearest 1,000, we always look at the next value digit, the hundreds, to figure out if we're going to round up or down. So anything between 3,500 and 4,499 will be correct. So there are multiple possible answers here. So I'm just going to write 3,501. So the next one, we're going to do the same thing. We're going to do a number line. This time we're going to write 820,000 in the middle, and the number could have it could be rounded up from a smaller number, or could have been rounded down from a larger number. So the nearest 10,000, so we're looking at this 2, so that means it's the 1,000 that we're looking at. So if this digit was a 5, it would get rounded up. So 824 and then 999 would be the largest it could be. And if we think that's that third digit can be a 5. 815,000 is the smallest number it could be. So both of these numbers that's the smallest number that would get rounded up if you're looking at the 10,000s. And that's the largest number. So anything in between this number and that one would work. So I'm going to write 821,000. But there's multiple possibilities with this. I would use a number line and just use your reasoning skills to figure out what's the smallest number it could possibly be, what's the largest number it could possibly be. I mean, you don't even need to do both. You could just think about what's the smallest number it could possibly be and you choose something from this range. Question 9. We have 4 calculations represented, and it says here 2 of these calculations have the same answer. Write this answer as a decimal. So there's a few things you could do here. You could either write the answer to each calculation next to or underneath the box and then look for the 2 that are similar, or you can use your understanding of using known facts. So the first thing I would say is both these are 4 divided by something. These cannot have the same answer. And the other ones are both 40 divided by something. These cannot have the same answer. We could also say that 4 divided by 10 can't have the same answer as 40 divided by 10, and we also know that 4 divided by 100 can't possibly have the same answer as 40 divided by 100. So you could use a bit of process of elimination here. And with division, when the dividend and the divisor both increase or decrease by the same number, they have the same answer. So we can see that this one, 40 divided by 10, and this one, 40 divided by 100, the 40 is 10 times bigger than the 4, the 100 is 10 times bigger than the 10. Because they've both increased by the same size, this is where the answer is. These are the 2 that are matching, but the question is saying write the answer as a decimal, so we'd need to do the actual calculating. So 4 divided by 10 is 0.4, and 40 divided by 100 is also 0.4. So like I say, the other way you could do it is you could have answered all of these. So that answer would have been 4 and that answer would have been 0.04. And then if you had have done, make sure your decimals are written better than I've written mine. If you had have calculated both of these, you would have seen these are both 0.4. Question 10, circle the 2 prime numbers that have a difference of 2. So a couple of different things. We're looking for prime numbers and they need to have a difference of 2. First thing we do is we eliminate any non-prime numbers, any composite numbers. 15, that's in the 5 and 3 times table, that's not a prime number. 25, that's in the 5 times table, that's not a prime number. 21, that's in the 3 and 7 times table, that's not a prime number. You can now see we're only left with 3 prime numbers, and these 2 are the only 2 that have a difference of 2. Question 11. This table shows the number of children and adults at a childcare centre. Complete the table to make it correct. The first row has been done for you. So we have age in years on the left, we have the number of children, then the number of adults, and the number of children per adult. This is the ratio. So there are 3 children for every adult. So you can see 3 children per adult. If there's 4 adults, times that by 3, there are 12 children. So we're timesing the number of adults by 3 or dividing the number of children by 3. In this next column we can see the ratio is 4, therefore we are dividing the number of children by 4, so our answer is 5. In our next row the ratio is 8 children per adult, so we are multiplying the number of adults by 8, that is 24. Question 12. Shapes W, X, Y and Z cover different fractions of this 10 by 10 square. If it's a 10 by 10 square, that means that there are 100 small squares inside, so we can think of each square as 100th or 1%. That makes it nice and easy when we're doing fractions. Now we need to match each shape to the correct fraction. I would look at this and I can see Y is only 1 square out of that 100, so I know that Y is going to be 100th. So we can straight away join up those 2. When I look at W, I can already see it looks like a quarter, but just double check. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It's 25 squares, 25 out of 100 is a quarter. That should be a known fact, so W goes to 1/4. Now we've got X and Z, we've got 2/5 and 1/10 left. So if I go to X, we've got 1 1, 2, 3, 4 columns. Each column has 10 squares. So we've got 40 out of 100, or we could think of it as 4/10 because there are 4 columns out of the 10 columns, and 4/10 can be simplified to 2/5. So x is 2/5. And we'll just double check with z. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 out of the 100, and 10 hundredths can be simplified to 1/10. Question 14. A class votes for a captain. 3/4 of the class vote for Sam. I'm going to highlight here, and the remaining 7 pupils vote for Alex. Now, how many pupils are in the class? Now, what we're going to do is we're going to represent this using a bar model, just so you can visualize. Now, I've done a bar into quarters because we've seen here we've got 3/4, and if we start to fill out the bar, 3/4 of the class vote for Sam, and the remaining 7 pupils, we know that's 7. Now these are quarters, so they're all going to be the same. So if we know that the remaining is 7, that quarter is 7, we know all of them are going to be 7. And we can use that to figure out how many pupils are in the class. It's simply 7 times 4, 4 lots of 7, which is 28. Question 15. Write the missing number to make this multiplication correct. We have 3.207 times 100 is equal to something times 10. Now this times 100 and this times 10, we can see that in the second equation it is 10 times smaller. With multiplication, if one side of our calculation is smaller, the other side needs to be bigger to balance it out. So if that side is 10 times smaller, this side needs to be 10 times bigger. So 3.207, you should be able to do that in your head, is 32.07. Question 16. Here is a number, 9,658,214. Use these separators to help you read a number. This separator is a million, this separator is 1,000. So it's 9,658,214. Tick the statements that are true. The digit 5 represents 50,000. Let's look at the digit 5, and yet that is worth 10,000. So that is in fact correct. We can tick that. The value of the 9 is 900,000. We look 9. No, that's actually worth 9 million. That is incorrect. I'm just going to put a cross there. The digit 6 represents 6 millions. We'll know that's incorrect because we know the 9 is the millions. And the value of the digit 2 is 20 tens. So 2 is 20 tens. It's 200. The 2 is worth 200. We just need to make sure that we see that it says 20 tens. 20 tens is the same as 200. And if we were to think about this as the tens, we've actually got 21 tens here, but the digit 2 is worth 20 tens. Question 17. Chen buys these 4 items. Chen pays for the 4 items with a £10 note. Let's highlight that. The price of the butter is not shown. She receives £3.85 change. What is the price of the butter? So this involves a couple of steps. Let's start with what we know. We know that Chen pays of £10 and that she receives £3.85 change. So the first thing we're going to do is to calculate how much everything has cost. So I'm going to zoom in, and we're going to start by calculating the £10 subtract the £3.85. Now I'm going to I've put in the decimals for £10. So £10 subtract £3.85. So we're going to start, we can't do 0 take away 5, we're going to have to pop along to our 1 and make that a 10 so that we can make it a 9, make that a 9 so that we can make that a 10. So we're just doing our borrowing exchanging. 10 take away 5 is 5, 9 take away 8 is 1, decimal point, 9 take away 3 is 6, and then we've got nothing there. So £6.15 is what she has spent. So we know that she spent £6.15, and we know the price of 3 of the items. So the next thing we're going to do is add up the 3 items that we can see the prices for. So I have written down the the numbers, the prices for the 3 items we can see, and we can just do a simple addition. So that's 5 plus 4 plus 7 is 16, remembering to put the decimal point in. 1 plus 1 plus 1 is 3. So the 3 items come to £3.65, but we know that she's actually spent £6.15. So we now need to find the difference between £6.15 and £3.65. And we would do that with a subtraction. So we're going to do £6.15 subtract £3.65, and just do that subtraction. 5 take away 5 is 0. We can't do 1 take away 6, so this is going to become a 5, this is going to become an 11. 11 take away 6 is 5, a decimal point. 5 take away 3 is 2. So the difference is £2.50. The butter must be equal to £2.50, so that all these 4 items now add up to the £6.15, which makes that £3.85 change make sense. So the final answer is that the butter is £2.50. Question 18. Draw an arrow on the scale below to show 1,350 grams. I'm going to just zoom in. If we look at the scales, we can see that we've got 1, 1.5, and then 2 is further up. 1.5 is the same as 1,500 grams, and 1 is the same as 1,000 grams. So we can use these little lines in between to figure out what the scale is. Now you can see there's a small line and a larger line. There's 1, 2, 3, 4, and then 5. So that tells us that these are all going up in 100. So this would be 1,100, 1,200, 1,300, and then 1,400. Now we want 1,350, so in between 1,300 and 1,400, that would be where 1,350 is, and we just need to draw an arrow to indicate that. So my arrow is pointing between the 1,300 and the 1,400 to indicate the 1,350 grams. Question 18. A hall has 1,250 seats. At 7 p.m, 880 seats are filled, and at 8 p.m, there are 40 empty seats. How many seats were filled between 7 and 8 p.m? Now, I would use the side here to annotate some of these clues. So I know that altogether there's 1,250 seats. 8 p.m. there are 40 empty seats, so I know I'm just subtracting 1,250. I'm subtracting 40 from 1,250, but I can do that in my head. So that would be 1,210. So I can just write that in there, just annotate it. At 8 p.m, that's how many seats are filled. And we know that at 7 p.m, 880 seats are filled. So all we need to do is find the difference between 1,210 and 880. So we can use our squares to do this calculation. So we're doing 1,210 subtract 880. So 0 take away 0 is 0. We can't do 1 take away 8. We're going to borrow from that 2. 11 take away 8 is 3. We can't do 1 take away 8. So 11 take away 8 is 3. There are 330. There's a difference of 333. Question 20. Each day a school has a break from 10:15 to 10:30 and a lunchtime from 12:40 to 1:30. What is the total time the school has for breaks and lunchtime in a 5-day week? So we need to make sure that we make note of the time period. So what we need to do here is let's first find out how much time is spent in a day, and we might want to annotate each line. So 10:15 to 10:30, that is 15 minutes. And 12:40 to 1:30, well 12:40 to 1 p.m. would be 20 minutes. 1 to 1:30 is 30 minutes, so altogether that's 50 minutes. So in one day we have 65 minutes or 1 hour and 5 minutes. Now I would be tempted to keep it as minutes until you get to the end, because we now need to multiply that by 5. It's going to be a lot easier to multiply the 65 by 5. Oh, saying that, you could do 1 hour times 5 and 5 minutes times 5. Either of those would actually work. So I've actually changed my mind. I'm going to do 1 hour and 5 minutes times by 5, because 1 hour times by 5 is 5 hours and 5 minutes times by 5 is 25 minutes. It's actually a lot easier. Either would get you an accurate answer though. So the final answer is 5 hours and 25 minutes. Question 21, we have a diagram with lots of letters labelled with different lines, 4 different lines, and we need to tick all the correct statements. AB is parallel to CD, so let's have a look at line AB and let's have a look at line CD. We can see that that is not parallel, that is not correct then. And the next one is GH is parallel to AB. So GH is parallel to AB. We can see those are parallel, so we can tick that that is correct. CD, which is this, is perpendicular to GH. Perpendicular means at a right angle. CD is perpendicular to GH. We can tick that. And EF is perpendicular to CD. Note they're in fact parallel, not perpendicular, so that is not correct. The only 2 correct statements are these 2 in the middle here. So you simply need to just identify the line, and it's just checking you understand the difference between parallel and perpendicular. Question 22. This table shows the distance that 5 friends travel to school each day, and you can see we have a column of names and then a column of their distance travelled to school each day. What is the mean distance they travel to school each day? The mean means that we have to find the total and then share it out equally. So we're going to find the total of all their distances and then divide it by how many people there are. Now you can rewrite these numbers out in a column here. I would actually just solve it directly on the table. So I would look straight here. So 8 plus 4 plus 2 plus 6 plus 5 we're going to do. Now there's various different strategies you can use. You could find groups, combine pairs of 10, so like the 8 and the 2, the 4 and the 6, they're 10, so that's going to be 20, and then 5 is 25, or you might just be able to add up as you go. So 2.5, sorry, 25, but we're putting the decimal point there and carrying the 2. Then 1 plus 2 is 3, plus 3 is 6, plus 1 is 7, plus 4 is 11, plus 2 is 13. So we have 13.5 is the combined distance, and then we need to divide that by how many there are. 1, 2, 3, 4, 5. So we're going to do that in a bus stop. 13.5 divided by 5, and pop that in a bus stop. 5 into 1 does not go. We're doing short division here. 5 into 13 goes twice, decimal point, with a remainder of 3, and 5 into 35 goes 7 times. So our final answer is, this answer at the top here, is 2.7. Question 23. Mrs. Mills has 940 seeds to plant into trays. She plants 12 seeds in each tray. The last tray is not full. What fraction of the last tray is filled? So there are a couple of steps to this. The first thing is to think about what calculation we're going to do. If we have 940 seeds to plant into trays, we can visualize these trays, and we know that there are 12 seeds in each tray. The first thing we want to do is find out how many full trays we can get in that 940. Now this is a division, so I'm going to zoom in very quickly. So we're going to do a short division, 940 divided by 12. It's short division because 12 is a times table that we can calculate mentally. So 12 doesn't go into 9. 12 into 94 is going to go, 8 times would be 96. There's not enough, so 7 times. And actually, I'll do it using the long division method so you can see. 7 times 12 is 84. so there would be a remainder of 10. If you're doing it short division, you'd do this in your head, 84, and then the remainder of 10 would go next to the 0 there, but instead we'll put it like this. So now 12 into 100. Now 12 into 100 is going to go 8 times. 8 times 12 is 96, so I'm going to put 96 here, subtract it, that's going to be 4. So I'm going to just write this as a remainder to begin with, so 78 with a remainder of 4. So my answer to my calculation is 78 remainder 4. What that tells me is 78 of the trays are full, and in the last tray there are 4 seeds, and there are a possible 12 in each tray. So there is 4 seeds out of 12. That's the fraction 4 12s. And you could just write it as 4 12s, but 4 12s can be simplified to 1/3. So our answer is that there is 1/3 of the last tray filled. Question 24. Here are 4 numbers, and then we have 4 numbers. Use each number once as in bold, to complete these statements. If it says once in bold, it's probably because these numbers might fit into more than one box. So we have a square number, a cube number, a common multiple of 4 and 5, and a common factor of 80 and 120. I can already see, for example, square number, there's two possibles, there's 6, 4 and 100. So I'm going to write next to each one the possible, so that could be 64 and 100. A cube number, the only cube number here is 64, so it's worth to know your squares and cubes. So I therefore know that it must be 100 for a square and it must be 64 for the cube. So we've now got 40 and 60 left. Is a common multiple of 4 and 5. Well, both 40 and 60 both are multiples of 4 and 5. They're both in the 4 and 5 times table. Is a common factor of 80 and 120. Well, 60 is not a common factor of, it's not a factor of 80, but 40 is a common factor of both. So that helps us to eliminate it. We have 60 and we have 40. Question 25. Write the missing numbers so that 3 times b subtract a equals 2. So here is an algebraic question, and what we're going to do is we're going to substitute. So for our first line, I'm going to write out the equation substituting the b, because I know what b is. So 3 times 2 take away a equals 2. So 3 times 2 is 6. So 6 take away a equals 2. So if we know that 6 take away something is 2, we know that the difference between 6 and a is 2. So we can use, we can invert this. We can do 6 take away 2 equals a. So 6 take away 2 equals 4. So that shows us what a is. So this is 4, and we can quickly check that. 3 times b, 3 2s is 6, take away a, 6 take away 4 equals 2. That is correct. Let's have a go at the other one now. I'm going to write it out again. 3 times b subtract a equals 2. This time we have what a is. So 3 lots of b take away 13 equals 2. This time we can go backwards like this. So something take away 13 equals 2. So if we add the 13, 2 plus 13, we know that 3 times b is going to equal 15. And then now we can see 3 times something is 15, or if we use the inverse, 15 divided by 3, so we're going to go backwards, is 5. So b must be 5. And then we can just check it. 3 times b, 3 5s is 15, take away a, 15 take away 13 is 2. That's correct. Question 26. Here are 3 translations on a coordinate grid. Tick the translations that are 4 units to the left. Now it's telling us the from and to. This is important. Now also what we need to remember is in a coordinate we have x, then y. Remember, x is left and right and y is up and down. Okay, so if we are looking for 4 units to the left, we're looking for the x coordinate. So if we highlight the x coordinate in each, in fact I'm going to zoom in. So I'm just going to highlight the x coordinate in each one. And to get from 0 to 4, we are adding 4. If we add 4, we're going that way. That's right. Adding is right, subtracting is left. From 6 to 2, we are subtracting 4. So yeah, that's going left. That's correct. And then from -3 to -7, that is also subtracting 4. So subtracting is going to the left. That is 4 units to the left. So these two, although they all have a difference of 4, only the second two are going 4 units to the left. Question 27. Olivia has 2 jars of beads. The number of beads in jar A is double the number of beads in jar B. And you've got a visual here so you can see that jar A is bigger and there's double. Olivia says 25% of the number of beads in jar A is the same as 50% of the number of beads in jar B. Explain why Olivia is correct. So this is really just about understanding fractions. I'm going to zoom in on the jars for this. Now, if you didn't have the jars there, you could do a kind of drawing of your own. But we know that jar A is double jar B, so we could say that's the halfway line in jar A, and if we halved jar B, that would be, if we're doing half of this half, that would be the quarter line. Okay, so 50% of the number of beads in jar B, that's half, is level with a quarter of jar A. So a quarter is the same as 25%, and a half is the same as 50%. So you could say something like half of a half, which is what this is the same as a quarter. A quarter is half of a half. Or you could draw a diagram and show that jar B is half of jar A. So half of that would be equivalent to a quarter of jar A, and a quarter is the same as 25%, and a half is the same as 50%.